Hi and welcome everybody to this first session on game design and development at FDG 2020. We will be having two short paper presentations and two full paper presentations. The short paper presentations have 10 minutes, that's 8 minutes for presentation and 2 minutes for Q&A and technical stuff, unless I'm misinformed. And 15 minutes in total for the full papers, 12 minutes for the presentation, and 3 minutes for setup and Q&A. 3 of these presentations are on video, so we're pretty sure they will keep time. There's a bit too many participants, so I'm not sure if all the authors are represented well here. I know that the third paper has its presenter here, and somebody then also who can answer questions. So I think we're pretty much set up to get going. The first paper is named Interactive Design Exploration of Game Stages Using Adjustable Synthetic Testers. It's a multi-author paper. I will not go through all the names. You can see them on the video, and then you don't need a bad pronunciation of the names either. So I would ask Renata, our tech support, to simply start this.
Hello, I am Hirotaka Suetake from the University of Tokyo. This talk introduces our work titled Interactive Design Exploration of Game Stages Using Adjustable Synthetic Testers. When designing game stages such as Super Mario Maker, game designers always need to consider player archetypes of the expected audience of the game. For example, for expert players, game designers needs to make a wider variety of hazards and stronger enemies. In contrast, for novice players, designers should make easy mode rules that the design stages are simple. That is, understanding the common play styles and skill levels required to complete the game is crucial for designing an enjoyable game for a wide base of player archetypes. The traditional design process consists of 3 steps: playing an under-designed game by actual players, collect players' feedback, and revising the stages and parameters. This process time-consuming and expensive because this process must be repeated until the designers is satisfied. Therefore, in order to improve efficiency of stage design process, we employ automated playtest approaches instead of actual testers, and propose a novel game-level authoring tool, called Mario Builder. This tool allows the game designers to intuitively understand which section of the game level contributes the most to the difficulty. In addition, we evaluated the effectiveness of Mario Builder with a user study. Okay. Here, I will review important works related to ours. There are a lot of methods to use artificial intelligence techniques to support parts of the game design process, for example tuning game parameters. Isakson make a simple tester and explore the high-dimensional game space, the relationship between game parameters and player experience. We inspire the concept of this system and extend this model to customize the play styles and skill levels for different complex games. Second, in order to make our synthetic testers, we also investigate methods to imitate human playing behavior. And we find a lot of research to use deep learning or MCTS-based approaches. In addition, some researchers have compared several methods of human-like playing, and they report that the MCTS algorithm is suitable for human-like behavior. Hence, we utilize the MCTS algorithm to make tester properties. Next, in order to understand the tester's playtests clearly, we also investigate visualization methods. One approach is to directly use gameplay scores from multi-agents playtests. However, a player's score focuses only on predicting a game's difficulty, and it doesn't provide information to understand where to refine the game stages. The other approach is to use a heat map, which is a color-coded representation based on event frequencies, such as locations where game characters often die. These systems enable users to understand the results of the tester's playtests visually. However, this representation is insufficient to support designing game stages because the designers must consider both the overall game difficulty and event frequencies. Therefore, we employed both playing scores and a heat map. In summary, our work combines these components. In case of AI-assisted game design, we use synthetic testers with MCTS method. In addition, we use a method to visualize the quality of the games based on testers playing scores and heat map. Next, I will explain our user interface. First, a game stage without any elements appears in the game view. The user starts by manually placing the stage elements such as hazards. Of course, the users can play a stage in development by themselves. Next, our system allows the users to set the AI bot properties with the setting bot function. In this paper, we empirically select 4 play style, runner, coin collector, monster killer, and scorer, and 3 skill levels, expert, normal, and beginner. When clicking the playtest button, the system simulates an AI-based playtest, and the users can see the simulation results as an animation of Mario behavior in the game view and difficulties on the visualization panel. Based on the visualization, users can qualitatively understand the game difficulty. Next, I briefly explain the detail of synthetic tester model. Basically, we use the standard MCTS algorithm. This algorithm is not our main contribution, so I want to skip the explanation of MCTS algorithm in this presentation. Of course, the implementation detail is described in the paper. If you are interested in this part, please check it. What I want to say is that the MCTS algorithm is easy to control player style and level by changing the reward functions or MCTS parameters. Here is a demo of some testers' results with different playing styles. This is a version of changing playing style and playing levels. We now move on to the next subject, user study part. The main purpose of the user study is to investigate the effectiveness of our interface in assisting users in understanding the characteristics of user-designed game stages qualitatively. We invited 12 participants. All participants had an amateur level of knowledge of game designing/playing. The task is to keep working on their stages until they were satisfied in the order, first without, then with the AI-based playtest. In the end, we asked the participants to evaluate comfortableness and overall usability using 5-point Likert scale. This is the result. We also calculated p-value by running a Wilcoxon-signed rank test. The results show that an AI-based playtest is more comfortable and had higher overall usability. In summary, by visualizing the AI-based playtest's results, the participants were able to understand where to improve in the current stage while balancing the game difficulty and the player's properties. Also, the user study results suggest that our system could significantly reduce the time and effort of game stage design required in practice. Lastly, I explain some limitation in future work. Our system focuses mainly on the visualization of playtests with bot play styles and skill levels. Therefore, users can only set up bot play styles, skill levels and design of the stages. However, it may be interesting to explore the possibility of extending it to include auto-tuning tools for optimizing stage components and tuning game parameters in the future. This concludes my talk. We present a game-level authoring tool that incorporates synthetic testers. Our system enables the users to intuitively understand where to improve in the current stage while balancing the game difficulty and the player's properties. Also, our system could significantly reduce the time and effort of game stage design required in practice. That's all. Thanks for listening.
So there are reaction possibilities you can do to make applause with still being muted, if you wish to. I have not been able to see that the authors are actually here. If you are, please let us know. There was a question in the chat, in case you missed it, if the videos would be made available to the general public later on. or at least people who have access to the proceedings of the conference. And the intention from the organizers is that this will be made over a couple of weeks after one has secured that one has the rights to do that, and maybe some light editing has been done also.
Exactly. Thanks, Stefan.
So if there is an author here, can you please request to be unmuted if you can't unmute yourself, and let yourself be known so we can ask some questions? Otherwise, we might believe that it's been an AI who wrote the paper and sent it in, and an AI who kind of talked in the video and so on. But that will have to be a mystery. I think we need to move on since we're on such a quite we have such little time to do it. So I think we should move on to the next presentation. This will also be a video. However, I have seen that at least the first author, Henry Bomström, is here, so we will be able to ask him questions. Renata, can you start the video?
Hello everyone, my name is Henry Bomström and I am from the University of Oulu from the research group Empirical Software Engineering in Software Systems and Services, or for short M3S. Today I will be presenting to you the paper Synchronizing Game and AI Design in Pcg-Based Game Prototypes. This paper has been co-authored with Markus Gelanti, Elina Annanperä and Kari Liukkunen from the M3S research group and Jouni Lappalainen from the Interact research group. As some of you might know, designing and prototyping games based on algorithmic creation of game content can sometimes be quite challenging. Digital prototypes are used to demonstrate core gameplay and mechanics, and oftentimes use mock-up game content instead of real game content. However, this can be an issue in procedural content generation-based games, which focus their core gameplay and mechanics around algorithmic creation of game content. Interaction with the content generation process is one of the key aspects required to reach new forms of gameplay, and this interaction can be hard to demonstrate with static game content. Unless the game and its content generator match well enough, the produced content can feel meaningless and disconnected from player actions. This can negatively affect the gameplay experience, and is a problem that can be present from the very first steps of prototyping. So what we decided to do was to extend the existing Pcg-based game design process and to provide a way of designing both the game and its content generator in a way that results in meaningful play. This can be beneficial as it helps us in addressing design issues and problems from the start, and may lower the required Pcg literacy for creating prototypes. In the next 10 minutes, I will present background for procedural content generation, followed by the prototyping case being studied, our solutions to the problems encountered in this case, and finally, implications for the results, limitations, and future research directions. First, some background. Procedural content generation, or PCG from here and after, refers to algorithmic creation of game content and has been around for quite some time. As you can see from the image, the game Rogue from the 1980s is one of the most famous examples of games using PCG. However, historically PCG has been mostly used in a supportive design role to enhance replayability, circumvent hardware restrictions, and to provide adaptability to game content. PCG-based games, on the other hand, focus core gameplay around content generation and could not exist without these generative processes. So what does that mean actually? Imagine a Super Mario map where instead of linearly navigating to the next level, you would interact with the content generator to produce a level housing Bowser and Princess Peach. By allowing the player to control the generation process, she can form strategies around content generation. This allows us to reach new forms of gameplay by interacting with content generation and possible AI elements. Designing gameplay experiences is an indirect task where the designer creates a game system that the player experiences through interaction. However, PCG-based games introduce another layer of indirection, as parts of the game's content might not even exist before the game is started. This makes it quite difficult to hand author gameplay experiences that rely on game content. Failures in content generation have been called catastrophic failures and can leave the game in an unplayable state. On the right-hand side, you can see the PCG-based game design process. This process has two main elements of interest: game design and AI design. Game design provides context for AI's decisions, while AI provides affordances for the new forms of gameplay. As you now know some background on PCG-based game design, I will now present to you the case being studied, that includes methods and study structure, the prototype case, and the problems encountered in said case. This study is organized as a single case study. First, we extended the existing PCG-based game design process with actionable steps and evaluated it by creating a prototype game. However, we did run into an issue where the prototype worked on paper, but the generated content lacked meaning. This negatively affected the overall gameplay experience. We resolved this issue by introducing the concept of meaningful play by Salen and Zimmerman to the extended PCG-based game design process. The prototype was a simple dungeon crawler that mimics Endless Web's portal mechanics. These portals affect different aspects of the generated levels, such as level structure, food, and enemies. The player steps through these portals to explore the different levels the generator can create in order to find objectives in certain combination of parameters. The early prototype was created in 2 iterations by following the steps in the extended design process. However, even though the levels were playable and fulfilled their requirements on paper, they did not produce the wanted gameplay experience and felt disconnected from player actions. So why is meaningless content and disconnection from player actions such a big issue? The game kind of works and does what you want it to do. However, if we fix it now, we can potentially save ourselves from various problems in the future and hopefully lower the number of iterations to get it right from the beginning. Digital prototypes are used to demonstrate core gameplay and mechanics that are in this case bound to the content being generated. The player's actions guide this generation process, and if the game doesn't produce a coherent response to the player's actions and correspond with the player's expectations, the player may feel to be at the mercy of a random number generator, as its decisions don't make any sense within the game. This issue can occur at the very first steps of prototyping, and we need to pass it somehow. As you are now more familiar with the case and the problem, I'll now introduce one possible solution and describe the extended design process we created. So, how can we bridge the gap between the game's context and affordances to produce more meaningful content that corresponds to the player's actions? To reach this goal, we can use the concept of meaningful play by Salen and Zimmerman, which states that the relation between player action and system outcome shapes the meaning conveyed during gameplay. To put it shortly, meaningful play occurs when the relationship between player actions and system outcomes is both discernible and integrated. Player actions can be seen to be discernible when the system communicates the outcome of a player's action in an understandable way, and they can be seen as integrated when the system communicates their effects on the rest of the game. As a practical example, the portal mechanic used in the prototype can be improved with the previous in mind. To make the portals more discernible, the change in the system state can be explicitly communicated through visual means by, for example, coloring the map tiles depending on the player's choices. The portals can be made more integrated by displaying how close the player is to each goal and whether the player has progressed towards their goals. This can seem as quite simple, but it is a powerful tool for considering the game's context and the AI's affordances. Sometimes it's not about what the generated content looks like in a vacuum, but how it is used in relation to the greater context of the whole game. When we put the extended steps and our solution together, it looks like this. I will first introduce the elements in red that can be followed to construct the game system. The game design side of the process follows the mechanics, dynamics and aesthetics framework that is likely quite familiar to many of us here. First, the designer can determine the most essential experience for the player and break it down to the most relevant aesthetics. The aesthetics are then supported by the underlying dynamics and mechanics. The AI design side has been depicted to show a search-based approach to content generation, however, this might vary between games. It is still important to provide the necessary interface for your content generator, the generative processes themselves, and to evaluate the generator. This evaluation determines whether the generator behaves as it should and that it produces the content we want it to. Next, I will introduce the steps in red that can be completed when transitioning between design phases or at the end of an iteration. If we want to define our game context more explicitly, we can do so by identifying the relevant system properties. As we transition from the AI design side, we should ensure playability and address failures in content generation. Finally, we strive for meaningful play by making sure that the relation between player actions and system outcomes is both discernible and integrated. As the prototype becomes more mature, the more this interaction matters. As for the implications of these results, traditional game prototyping models may not translate well into Pcg-based games as their core gameplay relies on content generation. Utilizing mock-up game content serves to validate secondary gameplay, such as combat with enemies and exploration of static levels, without realizing the unique design benefits of Pcg. Providing concrete tools for early-stage prototypes might still provide additional insight on how traditional prototyping approaches fit Pcg-based games and may help designers avoid issues further down the development process. The proposed solution may also lower the required Pcg literacy for designers and enthusiasts alike in translating their ideas into functioning prototypes. There are several limitations in this work that can be addressed in future research. The study has been conducted as a single case study, limiting its generalizability. The next step in future research is to perform empirical evaluation for the process. Lastly, further studies can be conducted on how traditional prototyping models fit Pcg-based games and how prototype maturity affects their development. So what to remember from this presentation? The generated content can feel meaningless and disconnected from player actions if the game and its generator aren't synchronized. To combat this, we presented an extended version of the Pcg-based game design process and provided a way of designing the game and its generator in a way that results in meaningful play. This concludes my presentation. If you want to contact me directly, you can do so with the email in the slides. I will now happily answer the questions you have. So, do we have any questions, or are we all just happy to be here? Can you hear me, by the way? Okay, so Divi asked in the chat, what did the after state of your example look like? How did the player experience change? So this is something I don't have pictures of, but this is still in some sorts work in progress that at least I plan to improve in the future maybe. So this player experience and the change it produces, this is something that we listed as future research in the paper to further evaluate on how does it exactly affect this player experience. This paper is more about these difficulties in the very first steps of creating prototypes. So when you create the first type of prototype, you can probably get away with using mock-up game content. But when you go into the next maturity stage, you can't use mock-up game content as reliably anymore. So you kind of have to have some sort of generative system in order to use the Pcg-based game design principles. So this is something that we need to make sure that in order to test this gameplay experience,
we need to have both the parts fitting together in order to at least have some results. So that's the next step, in my opinion, to actually do this more fine-grained player experience testing. Did I answer your question? Okay, you can ask details in email or Discord. I will be present.
I'm guessing Stefan had a problem with the connection, so I'm supposed to chair the next one. I think I will chair this one for the moment. So the next paper coming up is a paper presented by Pedro Beca, Monica Resta, Ana Veloso, and so on and so forth, called Developing a Toolkit to Make, Developing a Toolkit to Game Design. Are the authors present?
Yes, I'm the author.
Oh, it's you, Claudia. Okay, so while we wait for Stefan, I think you can just take the floor because we are running a very tight ship and we need to move forward. So please take the floor.
Okay, I will share the screen. Can you see it?
Yes, we can.
Okay, so I'll start. Good afternoon, my name is Claudia, and today I will present the development of Gamers for Nature Toolkit to Game Design. The starting point of this project was the widespread use of mobile phones and mobile games, the power of games, especially digital games, in behaviors change, in education, and including environmental education, the need to promote the environmental awareness in the youngsters, and the involvement of young people in the creation of digital games as a strategy to promote environmental awareness. The project goal is to involve youngest audience in mobile game creation, and by doing that to promote the environmental awareness. From the review, 3 approaches were considering as being the more in line with the toolkit of this project. That is Jules' perspective of game as a structure, Unique and his colleagues' MDA framework, and Fullerton's play-centric approach to game design. Taking into consideration the project target audience, Fullerton perspective was considering as being the most adequate for the project conceptual framework, as it presents an extensive description of several game elements and the relations between them. As this approach will benefit from further evaluation, experts and developers from game design field were invited to discuss each game element and the relation with the prototype, as you can see in this image. That is a set of hexagonal pieces with game elements disposed in a honeycomb tray. The analysis of the experts and developers' inputs evidence that although the pieces and the tray accomplish its goals, there was a need to redesign the pieces in order to accommodate more information of each game element. Aiming to keep a non-linear and dynamic perspective of game design, a new artifact was developed, that is the game construction card set. These cards have a trigger question and an explanation of each game element. Then participants considered the cards useful and easy to use, but some of them felt some difficulty in structuring game narrative. So we developed the rapid game design document printed in the A3 format in order to explain in a more detailed way how to construct a game narrative while using the card sets. These documents evokes a game table board, and the users can write while brainstorming and planning the game that is being built. Then, in order to assist the construction of narratives, resources focused on an environmental preservation theme were developed. The first one that we decided to approach was the microplastic pollution, and it followed the same trigger question and explanation in each card. As for the content, it was organized in 4 categories. Did you know, the yellow cards, that address objective information and characteristics about microplastics, but after all, sorry, did you know, are the pink ones, but after all, the yellow ones focused on how microplastics are created and discarded. Truth or lie, the purple ones, fact checks about truths and myths about microplastic pollutions, and take to action, the green ones. that have simple and easy suggestions and insights that are able to help people to change habits and behaviors. The packaging was made in cardboard and MDF, that is medium density fiberboard, and allows the accommodation of all the Toolkit resources, the game and thematic cards and the rapid game design document, keeping them in place even when the box is moved from one place to another. It's similar to a book cover and presents instructions on how to use the toolkit, which made it simple and easy to use. All the resources and templates are also available in the Gamers for Nature website to be downloaded and adapted to other scenarios. On the website, there is more info about the project and also is used as a repository for the mobile digital games created in game design sessions. All these resources were developed following a participatory design approach with experts and potential end users in the design and evaluation process. It took place between May and November of last year over 5 stages. The first one was the definition of the toolkit's conceptual framework. And as I mentioned before, experts and developers from the game design field were invited to discuss each game element and the relations between them. It was stated by all the participants that both the table board and the pieces were a valuable artifact in the exploration of game design concepts, allows for different ways to group the elements and also to articulate different ideas. Nevertheless, they mentioned that in order to be used by a younger and less experienced audience, the pieces will need to be redesigned to accommodate more information. Therefore, the next stage was the development and evaluation of the game construction card set. Focus group with the target audience were taken, focused on the construction of a game narrative with the cards. Participants stated that the cards helped them conceptualizing the game and considered the test easy and clear and objective. So it was easy for them to understand and process the information, even though some participants asked for help because they were not able to understand how to use the cards. This indicated that some guidance would be needed. This led us to the third stage, the development and evaluation of the rapid game design document. It was possible to conclude that an instruction guide was needed. So this document was designed taking into consideration the participants' inputs, presenting a path to explore the game construction card set and the relations between the different game elements. This document was validated during game narrative design sessions held with undergraduate students from ICT and non-ICT courses. And along with those sessions, participants use the document to outline a game narrative and consider that it accomplished this purpose. Then we developed and evaluated the thematic cards. These cards were validated by experts in science didactics and design, and also by design students. The science didactics evaluation focused on the scientific accuracy of the content and the discourse's adequacy considering the target audience. Experts explored the thematic cards one by one, and they suggested minor edits to the text in order to make it more understandable and also scientifically accurate. And the design experts explored the cards by looking at the overall design and considered it appealing, mentioned that both colors and illustrations were suitable, and that the font size allowed for an easy reading. As for the design students, they pointed out the card shapes, colors, and the overall concept as interesting. Then finally, the toolkit's overall evaluation during game design sessions. All the resources were used and validated by the target audience, enabling them to develop a prototype of a playable digital game addressing an environmental theme, showing that the toolkit achieved its purpose. Participants mentioned also that the toolkit was a funny way to learn more about the environment, and it was really easy to follow. This easy reading of all the resources and the supports given by the rapid game design document were mentioned as being the most positive aspects. In conclusion, the toolkit was able to provide to experienced and unexperienced users a set of predefined educational resources addressing an environmental theme, and assisting them in their narrative development and game construction. Nevertheless, a few limitations should be considered for this research. The first one was the selection of the participants that was made through convenience sampling, not allowing for the generalization of these results. Moreover, there is also a discrepancy between the number of ICT and non-ICT students, and this does not allow for comparisons between the outputs of each group. In the next stage of the project, the toolkit will be introduced to a wider audience through game creation sessions and also game jam events. Additional thematic cards are already being made and will be validated through the same methodological approach. The results presented in this paper make it possible to expect that the Gamers for Nature Toolkit to game design will represent an important contribution to the promotion of environmental awareness within younger audiences. And also is expected that the promotion of game design activities may contribute to foster the development of soft skills such as working teams, creativity, and also to solve problems, skills that nowadays are increasingly valued in society. Thank you for listening to me. Please, if you have any questions, you can email me or you can visit our website. Thank you.
Thank you. And sorry for dropping out. My computer crashed. So I do actually right now have very limited view. I could hear and see the presentation. I don't know how we're looking time-wise, but if there is a question, I think we should take at least one question. So if somebody else in the conference can, you can simply unmute yourself or request to be unmuted and ask one question. We'll give some seconds for doing that.
Hi, I'll ask a question actually, Claudia. Thank you for the presentation. I'm just wondering how generalizable you think this sort of process is to other types of topics. I think the topic that you chose was really interesting, but I can think of a few other topics that I'd maybe want to, use the same kind of approach to. So have you got any sort of insights into that?
Yes, we really think that our toolkit, we chose this theme, the environmental awareness theme, but we think that it's really easy to adapt to other themes because we provide the resources, and the resources can really be adapted to what we want, basically. And I think the process can be the same because in each stage we add participants, so it's more easy to understand if the development is really okay, or if it was the final product, we didn't know what went wrong in the first stages of the development. So I think it's a good way.
Okay, thank you. And I hope people can find the applause reaction to show their appreciation. I unfortunately can't find it on my phone here. I think we do need to move on to the next short paper. So we thank you, Claudia, for the presentation. The next presentation will be on a video, expanding wave function collapse with growing grids for procedural map generation. And I ask
hello, and
hello. Can people hear me?
And welcome to the presentation on expanding wave function collapse with growing grids for procedural map generation. I am Tobias Novi Møller. I made this project with Jonas Axel Billeskov and with our supervisor George Palamas. We made this master thesis in 2019 from Aalborg University, Copenhagen. And now Jonas works with Ballback Games and works on the project Worlds FRVR. You can check it out at the link on the screen. I work on some minor projects. You can check them out at the link on the screen, Tobias Novi at wordpress.com. On the screen now you can see the final output from our project, where we're generating these cities, where wave function collapse ensures that each tile that is set naturally and it makes sense where it's set. And the growing grid creates this distorted look of the map. We'll go into more detail about these two algorithms. Wave function collapse is the algorithm we use to place all the tiles in this project. And wave function collapse is an algorithm developed by Maxim Guman, and it's inspired by quantum mechanics, where in an unobserved state, a particle can be anything, and the more you observe it, the less possibilities there are. And the way it works in this project is that each time you place a tile in the grid, it constrains the cells next to it on what kind of tile it can be. As you can see in the GIF, each time a tile is placed, the number goes down in the cells next to it, and the number is the different possibilities it can be. So you can see in this project we use 15 different tiles, so each cell has the number 15 right now. And one of the things about wave function collapse, which is nice, is that you can make a tile set which is as big as you want it. Each tile is only based on its neighbors and which tiles you can set next to it. Some of the recent project which has made wave function collapse more popular is Townscaper and Bad North by Oscar Stolberg, where he utilizes this algorithm. And Bad North is a game, and Townscaper is more of a way to make cities. In combination with wave function collapse, we use the algorithm called growing grids. It was developed by Bernd Fritzke in 1995. And the algorithm generates a rectangular grid through a self-organizing growth phase. So through a series of steps, it either adds a row or a column, but makes sure that the grid is always rectangular. The grid is then adapted to an input shape through an adaptation phase. This makes sure that the final grid is in the same shape as the input figure, as you can see in the GIF. And it also makes sure that it's a rectangular grid, which is needed for wave function collapse to work in it. We combined wave function collapse and growing grids, and to do this, we used something called blend shapes, where you take a model, as you can see on the screen. This is one of the roofs, and you can interpolate between two extremes, and this allowed us to always make sure that each tile could fit in the cells of the grid, even though it became very distorted. Another possible solution for this is marching cubes, but we like the simplicity of blend shapes and decided to use that. Another consideration we had to take while developing this project was to choose a tile set which is suited for the theme and specifically suited for these distorted grids. And we thought this city with some distorted roofs and roads and walls makes a lot of sense and looks good, but it's important to think about which tile set you use for this kind of project. While working with wave function collapse, we explored some different things that we thought was interesting. One of the things was using Grayscale Maps to control the distribution of blocks. As you can see in the first picture on your left, we used the black color to control where there would be walls in this desert-like tile set, and white to make a floor. Another thing was controlling the cell size through Grayscale Maps. You can see in the middle picture that where there's white on the grayscale image, the cells are a little bit larger than where they're black. And the last thing was making a pathfinding system with an algorithm called chiseling. So chiseling works by slowly trying to remove cells from a path until there's only a single path left to be that can be walked between different waypoints. And as you can see on the GIF, it creates the rest of the world outside that path. To evaluate this project, we made a test setup where participants would navigate in either a map with a regular quadrilateral grids, as you can see on the image, these straight maps, or they would navigate a map which had been distorted by the growing grid algorithm. After they had been navigating the maps, they were asked to specify which map they had been traversing in from the image you can see on the left. And the evaluation showed that participants were able to form better mental images of the maps which had been distorted by the growing grid. Thank you for listening to our presentation. We are looking forward to the rest of the conference. And if you have any questions, George Palamas will be answering questions after this.
If you have any questions, ask them in the chat or unmute yourself. Has there been any questions? I think I was muted, unfortunately.
Well, I think someone is talking, but I can't understand. Like I hear some.
Yeah, I did hear something like that also. Hopefully that person will fix their sound. I'll ask one question. So how easily does this way of producing an environment handle more holistic aspects, that you want there to be one region with forest, one with water and so on, since it seems to be using local information all the time? I'm not even sure that the speaker is here, so let me know that also, the rest of you. Should I interpret the silence that everybody else has left? I'm sitting on a mobile phone, so I can't see participants and I can't see the chat.
No, there's many participants, and I think I personally would have a question, but I'm not sure if any of the authors is actually present.
I think the authors aren't here, are they?
Oh, yep. The online conferences is an interesting thing.
Yeah, sorry about this. We're trying to sort it out.
Yeah, and sorry for my setup failing. I thank all of you who have participated here. It was nice to see several names I recognized personally, and I think the papers were interesting, and hopefully that the conference is reduced in time allows people to actually contact each other through social media and email and so on and discuss these things. I've seen a couple of things I'm probably going to be pointing out to students next year, I can tell you. That being said, unless Antonio wants to say something at the end, I will say that this session is finished, and it was nice seeing so many people here.
Yes, thank you, Stefan. It was it wasn't the most smooth conference, but let's hope that we're going to learn. And next up, we have the Games Beyond Entertainment first session. So we'll reconvene at exactly the hour. Wherever you are, 4 o'clock in Malta, and you can figure out the rest. Stefano Guadleni will be chairing.
Thank you.